Hey everyone, in this video I will do fine-tuning of Pegasus model for text summarization and then apply that fine-tuned model on a famous Hugging Face dataset called Samsung dataset. Let's quickly look at the dataset here. Alright, so this is the dataset on which I will apply the fine-tuning model to do my evaluation. So just a quick look at the dataset. You can see the first column is just unique ID, then I have the actual dialogues and then summary of the dialogues. So these dialogues, it can be some e-commerce website chat dialogue between consumers and the help desk. So that's kind of the way to make sense of this dialogue, and then the summary of the whole dialogue. And about the dataset, the Samsung dataset contains about 16,000 messenger-like conversation with the summaries. Conversations were created and written down by linguists fluent in English. Linguists were asked to create conversation similar to those they write on a daily basis, reflecting the proportion of topics of their real-life messenger conversation. The style and register are diversified. Conversation could be informal, semi-formal, or formal. They may contain slang words, emoticons, and typos. Then the conversation were annotated with summaries. It was assumed that summaries should be concise brief of what people talked about in the conversation in third person. So that's the point important. The Samsung dataset was prepared by Samsung Research and Development Institute, Poland, and is distributed for research purpose. Okay, so that's the fundamental of the dataset. So here, the basic purpose or the basic motivation of creating summarization of this chat conversation is that generating accurate summaries can help improve customer service and detect common patterns among customer requests. So it has quite a bit of commercial application. And so I am right in my notebook. Obviously you need GPU, so first I'm just checking with NVIDIA SMI what's the GPU I have, and I was running it in Colab, so I got a T4 with 16 GB GPU. And you need to install these transformer, sentence piece, dataset, then rogue score for calculating the evaluation metric, and obviously you have to import all these regular modules from the transformer. And then I am loading the dataset with this load dataset module of Hugging Face. These are all pretty standard and boilerplate code that you see here, right here. So I'm just defining the device, then the model checkpoint, defining the tokenizer by passing the model checkpoint, which in this case is Google, Pegasus, CNN, Daily Mail. And then I am creating my model by doing auto model for sequence to sequence LM from pre-trained model checkpoint and passing that to device. Now here I have two function here, two little util methods which are important. And just before this video and the immediately preceding video I did on text summarization and evaluation metric of my generated text. So these two functions, their purpose is to calculate the evaluation metric, specifically the rogue score. So the first method is we'll just generate a batch, and then the next method, that is calculate metric on test DS, will use this first method to generate a batch and then ultimately create a score, that is a rogue score. So the strategy here is pretty simple. First we split the dataset, that is in this method we split the dataset into smaller batches that we can process simultaneously. Then for each batch, that is now I'm coming in this method, for each batch, because so these two lines I'm just generating two batches, article batches and target batches. And here article means actually the whole text. In this case you can imagine these whole actual dialogues, and the target batches are the summaries, that is this column right here. Okay, and so these two lines will just create two batches, and then I am going through batch by batch, that is I'm looping over the batch and creating my tokenizer. that is inputs equal to tokenizer, and passing the article batch and the other parameters like max length, truncation, padding, etc. Creating summaries. So this summaries is actually the model generated summaries, because I'm doing model.generate and passing input IDs. From there I'm taking input IDs. And so we use the same generation parameter as was proposed in the original paper, and you will see a particular penalty here I'm doing while generating the summary, length penalty. So this what this penalty does is that it will apply a penalty to ensure that the model does not generate sequences that are too long. And ultimately, from these second method, calculate metric on test dataset, ultimately I will. So basically, I am creating inputs, tokenizer, I am generating summaries, and I am then decoding the summaries, and then I'm applying the metric.add batch. I'm applying this metric from Hugging Face to generate my ROG score by comparing the predictions and the reference. So the prediction is my generated summaries, and the references are actual summaries. And then in this cell, all I'm doing, I'm just printing an actual dialog, an actual summary. So you can see that, and I'm doing both of these on the test dataset. So first I'm printing from dataset Samsung test and 0, that is the very first dialog, and also the very first summary. So this is how the dialog goes. You can see that two people are talking, Hannah and Amanda. So Hannah is asking, hey, do you have Betty's number? Amanda says, let me check. Then Amanda says that, sorry, she doesn't have the number. And ultimately, Amanda advising Hannah to check with another person for the number. And the summary very succinctly creates a single sentence for the whole conversation, and it says Hannah needs Betty's number, but Amanda does not have it. She needs to contact Larry. So this is exactly and very correctly the summary of this whole conversation, and that's my actual real summary from the dataset. And now the job of this fine tuning is to train my Pegasus model and create this summary from my trained or fine-tuned model. All right, that was enough of the initial starting of the project, and now just keeping my head down and coding the fine-tuning of Pegasus. So I'm using pipeline of Hugging Face to create this summarization. First, we will run the summarization pipeline with Pegasus to see what the output looks like. So pipe out. Dataset. Quickly check that's the name of the column here. Pipe out. Let's just print pipe out and see what I get. So when you print pipe out, this is the output that you will get. You get a list, and the list contains a dictionary, and that has a key of summary text and then the whole text. And there are quite a few of these this particular token over here. So I need to replace this with just a new line character. So let's go to my VS Code. So what I'm going to do, actually just proceed to calculate my rogue score for now. No, actually just let's just remove these, replace this with new line character and see my summary text in a very clean format so that I can make sense. Yeah. So when I pipe out the 0th element, that is this whole dictionary, and then take the summary text, replace these character with new line, I get a finely formatted conversation like this: Amanda, Hannah, Amanda. Yeah, that looks good. And now I will move to calculate my rogue metric. So I'm just calculating rogue 1, rogue 2, rogue L, and rogue L sum. And what are they? I have already discussed in my immediately preceding video, where the focus was on to understand the evaluation. The focus was on generating summaries from a long text, and then doing all this evaluation metric and what these different rogue scores represent, etc. So if you have not already, do see the previous immediately preceding video, and then these will be much clear. All right, I need to define rogue metric. Data set. Rogue metric. And column summary would be and then if measure for RN So this will loop through all my rogue names. That is, I want to all these four different rogue metrics, and then take the mid.f measure and produce a dictionary out of that. And I just want to print this in a nice pandas data frame. Rotate. Pegasus. Okay. And next, what I want to do is actually, all right, but before proceeding, this is the pandas data frame with the rogue score. And as you can see, these scores are actually quite low. They are not good at all. And that's expected because these Pegasus model that I'm using, that's not properly trained for this particular Samsung dataset. And that's the whole purpose of this exercise right now, that I am going to fine tune this Pegasus model further for this data set so that the rogue score becomes much more sensible and much more accurate. And so that's the whole reason that I printed this rogue score before fine-tuning the model at all, so that I could see that these scores are really bad before fine-tuning. And next, I just want to create a histogram of the length of my dialogues and the summaries. So I need to plot a histogram, and the reason that I am doing this is to just to check that what is the average kind of length of the token uh, for dialogue and summary, and what is the maximum, what is the range of length, token length, where the maximum occurrences are happening for both the dialogue and summaries. For this, first I need to calculate the dialog token length. So DIALO, that would be len of tokenizer train LOGUE. LOGUE, yeah. And I need to do the same for the summary. Summary. Define a subplot. Subplots. One row, two columns. That's how I want it. It's SHAREY. That's the one I want to choose. Give it say 0. And a few other things I need to set, like title, X label, Y label. Okay. And oh, I did not set these X is 0 haste, the most important line. So the first plot is about dialogue token length. Beans of 20. Edge color. And I also need to do the similar thing for the summary. That's axis 1, histogram summary. The rest of the things remain same, and here as well I need to do this. Okay, and when I run this, this is the output I get. And so looking at this plot, we can see that most dialogues are much shorter, relatively shorter actually, with 100 to 200 tokens per dialogue. Similarly, the summaries are shorter as well, with around 20 to 40 tokens, the average length of probably a tweet. So let's keep this observation in mind, because now when I define my training configuration, these numbers will be important, because here I can see that probably there is no more data after like 700 length. So while configuring my model training for fine tuning, the maximum length I will set at 1024 for the dialogues and 128 for the summaries. And now I'm going to write a little util function for converting the examples to features. So this function will return me the input IDs, attention, mask, and labels as a dict. get the input encodings just by implementing or invoking tokenizer. That I pass the actual text of the dialogues. Dialogue. Yeah. With okay, now I'm going to define a context manager, and I will talk about this particular context manager that here I'm going to use in a second, but let's just complete the code. And this context manager is tokenizer as target tokenizer. Tokenizer dot and this context manager is only for getting the target encodings. Because now I'm concerned about the target, that means I need to capture the summary column. Maximum length, as we discussed, I will set it to 128, and okay, now just return a dict which will have input IDs encodings, and then inside I should have okay. Now I also need attention mask. And the last one is labels. Now I'm going to, the function is over. I'm just invoking this function now. So let's define the result of invocation of the function as data set sumsum pt, which will be equal to And now coming back to these context manager as target tokenizer. So this temporarily sets the tokenizer for encoding the targets. It's useful for tokenizer associated with sequence to sequence models that needs a slightly different processing for the labels. The as target tokenizer method is specifically for sequence to sequence model in order to separate between the source and target tokenizers. You don't need it for other kind of models, like not needed for Roberta. It just doesn't do anything for models that are not sequence to sequence. So with this tokenizer as target tokenizer, I am pretty much setting the context here because some models require special tokens in the decoder inputs. So it's important to differentiate between the tokenization of encoder and decoder inputs. In the with statement, that is a context manager, the tokenizer knows that it is tokenizing for the decoder and can process sequences accordingly. So that's very much the a reason for using this context manager. And now I am going to define the data collator. So I'm just importing the data collator for sequence to sequence in the first line, and then invoking that class and creating an instance of this class by passing tokenizer and model to my data collator. Now, what is a data collator? It's just data collators are just objects that will form a batch by using a list of dataset elements as input. These elements are of the same type as elements of train dataset or eval dataset. And in order to be ready to build batches, this data collator info classifier may apply some processing such as padding, or for some data collator also actually apply some random data enhancement as well on formed batches. And now finally my training configuration for the fine-tuning. So I'm just going to import the training argument and the trainer class, and then define all the configuration. Training args, training arguments. So here my configuration that I'm going to pass are quite a few. They are this: output dir, number of train epochs, warm-up steps, per device train batch size, per device eval batch size, wet decay, logging steps, push to hub true, evaluation strategy. Remember, push to hub true. If you do not want to push to hub true, you can just omit it. Something like this. Evaluation strategy is steps, evaluation steps, save steps, and finally gradient accumulation steps. And after this, you just have to invoke the trainer class. There as well, I need to provide all the arguments. So these are my arguments: model, args, tokenizer, data collator, train dataset, and eval dataset. Okay. And after this, just run your training. Trainer.train. Okay. And after the training, I also need to get my score. So I'm going to use the very first function we defined, which is calculate metric on test DS. And that takes data set. Because I'm calculating the metrics on the evaluation dataset, that is test dataset. And also I'm going to use rogue metric to be returned from this function. Model, tokenizer, maybe just 2. Dialog column summary will be summary. RN, and then I need to get the score. So these meet.f measures, these we have already discussed in my immediately preceding video, which was initial video on text summarization and doing basic evaluation by measuring the rogue score for 3 different models, that is Pegasus, GPT-2, and BART. So you can, if you have not seen that video, do watch that one first, because that will clear some of this concept here, that how these scores are calculated, what this rogue score means, the interpretation of rogue score, etc. Rogue names. Syntactical mistake here? No, it's all right. Yeah. And lastly, I just want to represent this rogued dictionary in a pandas data frame properly. So pandas d rogue date Pegasus Pegasus. And finally, when my training is over, this is a rogue score I got. That is rogue 1, rogue 2, rogue L, and rogue L sum for my fine-tuned Pegasus model. And as we can see now that these scores has improved quite a lot from before the fine-tuning. So before the fine-tuning, because Pegasus is not really suited for the Samsung dataset that we are using, so the rogue score was really bad when we calculated the rogue scores on the test dataset. But after the fine tuning of the model, when I calculated the rogue scores, it has really improved substantially. And that's the very purpose of doing my fine tuning. But before moving forward, a quick word on these particular parameter in my training arguments, which is gradient accumulation steps, and I'm setting it at 16. So since this model is quite big, I had to set the batch size to 1. That is both my per device eval batch size and per device train batch size are set to 1. However, a batch size that is so small like 1 can hurt convergence. To resolve that issue, we can use a nifty technique which is called gradient accumulation. And that's what this argument is all about. So as the name suggests, instead of calculating the gradients of the full batch all at once, we make smaller batches and aggregate the gradients. When we have aggregated enough gradients, we run the optimization step. Naturally, this is a bit slower than doing it in one pass, but it will save you a lot of GPU memory, and that you will quickly see it's a super important parameter while deciding your training parameters. Alright, so finally I am ready to test the fine-tuned model on the test dataset. So here's that code. Basically what I'm doing, I'm just first with this line I am defining the keywords for the fine-tuned model, and their length penalty, number of beams, max length, and then this is my actual sample text from the dataset. This is the actual reference from the dataset again, and as you can see, what I'm doing is I'm picking the test dataset, taking the first row, that is the first element or the first input value among the many, and taking the dialog columns value. That's my sample text. Similarly for the reference, I'm doing exactly the same, that is taking the first row only from the test dataset and only the summary columns values. All right. And then with the pipeline, I am just defining this little pipeline over here because this is a summarization task. I need to give the summarization as a first argument to pipeline, and the model, I have to define the model that I'm using. And then that's pretty much it. And all I'm doing in the next couple of lines, first I'm printing the actual dialog, then I'm printing the actual reference summary, and finally with the pipe method, I am printing the model generated summary. That is all. And for generating the model generated summary, all you have to do is to the pipe, you pass your sample text, you pass your generated keywords, then take the 0th element and summary text. Okay, let's see the result. Okay, here is the output of that code. So first, this whole thing is obviously the actual dialog from the dataset, and this is the reference summary of this whole dialog, but this summary was the actual one, that was already given in the dataset and it was written by human. And then finally, the most important part, the reason that we fine-tune the model is this one. So this is the model generated summary of this whole conversation. Okay, and let's see the difference. So the reference summary says Hannah needs Betty's number, but Amanda doesn't have it. She needs to contact Larry. And the model generated summary is Amanda can't find Betty's number. Larry called Betty last time they were at the park together. Hannah wants Amanda to text Larry's instead of calling Betty. Beautiful. This is absolutely beautiful. So these three lines pretty much summarizes exactly what happened in these dialogue. And that's our fine-tuned Pegasus models generated result. Alright, that pretty much wraps up this video. If you have liked this one, smash the like button. And also do subscribe, because I'm going to do many interesting NLP projects over the coming days and weeks. So see you in the next one. Thank you very much for watching.